Okay, well, thank you very much for coming to today's session on strategies that enhance understanding of integers. It probably will not take us an hour and a half to get through all of this stuff today. So in respect of everyone's time, I will just get started with today's session. I'll start off with the land acknowledgement. The ARPDC respectfully acknowledges that we are located on traditional lands across the province of Alberta on Treaty 4, 6, 7, 8, and 10 territories. The traveling route, gathering place, and meeting grounds for Indigenous peoples whose histories, languages, cultures, and traditions continue to influence our vibrant community. We are grateful for the traditional knowledge keepers and elders who are still with us today and those who have gone before us. We recognize the land as an act of reconciliation and gratitude to those whose territory we reside on or are visiting. Honoring the land in this way acknowledges the story of the creation of this country in a way that has historically been missing. So I'll start off with introducing myself. I don't know if you all know me. Hi, Larissa. I am a former teacher of Greater St. Albert Catholic Schools, and I retired a few years back, and I also work for Edmonton Regional Learning Consortium for giving professional development sessions, and this year especially in the grade 4 to 6 curriculum. And I am retired. Like I said, I am retired, so I'm looking forward to traveling, and I have 3 daughters, and life is great as a retired teacher. Just a quick overview of number concepts when we're looking at the kindergarten to grade 6. The thing that we're dealing with today is integers. Kids really have to have an understanding of numbers and fractions and decimals before they get into integers. But the grade 6, what's new is not only do we now introduce integers, but we also do addition and subtraction with integers. And really, if we teach kids conceptually using manipulatives, that really is not going to be difficult. No one's going to be asking you to do, adding and subtracting positive and negative numbers that are in the thousands or 10,000s. Just go up to 20, both positive 20, negative 20, with the adding and subtracting, and they'll be just fine. So if we look at the cusps, you'll notice that, what is the knowledge that kids have to have? They have to understand that negative numbers are on the left of 0 or below 0. Positive numbers can be represented without or with the positive sign, and negative numbers always have to have the negative sign in front of it. 0 is not positive or negative. And kids need to know that there's symmetry on both sides of the number line that starts at 0. It's on the left and the right side of 0. And the direction is relative to 0, is indicated symbolically, whether it's a positive or a negative. Now, the big thing here is the skills and procedures. Whenever you're looking at the skills and procedures in your curriculum, look at the verb. And the verb in this case is identify. They're identifying negative numbers. They're expressing positive and negative numbers. They have to relate magnitude to the distance from 0. Magnitude is like how far is it from 0. And then they have to relate positive and negative numbers, including their additive inverses, to their position on the horizontal and vertical model of the number line. Also, comparing and expressing the relationship between two numbers as something is less than, greater than, equals to. So the big thing here is really take a look when you're dealing with this curriculum that you're looking at those key verbs. And so when we get into adding and subtracting with integers, you'll notice that one of the key verbs is investigate. The best way to investigate is using your integer tiles, like two-sided tiles. You could use 2 different colors of bingo chips. Also express 0 as the sum of 2 integers in multiple different ways. Multiply, model the sum, model the 2 positive, 2 negative, and positive and negative. So in the end, we want them to add any 2 integers. And then also when it comes down to differences, subtraction, we want kids to express a difference as a sum. So one of the nicest things is my colleague Tammy, who works for ERLC. She used to be, by the way, she used to be the consultant for Edmonton Catholic. She put together a really great document that is the key words, the key verbs, and she's defined everything for you, and it's all hyperlinked with a toolkit. So if you're looking at those words, and I'm going to put this in the link for you in the chat. And you know what? Actually, you know what I'm going to do is I'm going to give you right now my entire document with all the links that I'm going to be going through. And then I won't have to go through this again. So on this document that I'm giving you right now, it has all of the links to everything that I'm going to be relating to. So when you're teaching integers, just pull up this document and it'll help you out with everything. I also gave you in this document, you'll notice the third thing from the bottom is these slides. So you have, when you're teaching adding and subtracting, you can actually use these slides to help you out. Okay, so Tammy did this, and then Tammy also did these beautiful cards so that you can actually use these cards in your classroom. You can just make a copy of them, and they're the definition cards. And this one in particular comes from K-3 because the word identify actually starts off in earlier grades. So we want kids to identify, that's to recognize by name or indicating what it is. And
so
then
it's not a separate document. There's not a K-3 and a 4 to 6. It's all one document.
No,
okay.
There is a 4 to 6, and you'll notice that I gave you the K-3 and the 4 to 6. But okay. I will add to this document after, because I didn't have the proper link for the 4 to 6s. So I will add that right after the session. Tammy said that she sent it to me. I just noticed a text that she sent it to me in my thing. So I'll just open it up and it'll be there. Okay. But these are words that are in the grade 6 curriculum for integers. They have to express. And so that means to express something is to show that they understand it and they know it. And then there's all these K-6 resource components that there's a glossary, there's the definition cards, and the teaching toolkits. So like I said, at the end of today, I will make sure that those links are in here in this document, so you have them all for all K-6. And just remember, if you go back, let's just go back to this here. The ones that are yellow highlighted, those are words that are actually that come up in grade 4 to 6, but their toolkits and their their posters are in the K-3 pile. Okay. So when I saw that, I thought, I wish I had that when I was teaching, like just to say to the kids, okay, this is what, and to the parents also, like when you're doing report cards, you're really going to want to be able to show the parents that they can express what is a negative number, what is a positive number. So the real life use of integers is all around us. The biggest one is sea level. Everything is like compared to sea level. So for example, anything below sea level is a negative number. Anything above sea level is a positive number. But the one that kids in grade 6 are most familiar with is the thermometer. And honestly, I love the thermometer to be used as a number line also. It's great, especially when you get into adding and subtracting. And then things like if any of you are golfers, the golf game is based on positive and negative numbers. At par is that you golfed equal to what they said you should do. So if you under par, that means you actually, like for example, 1 stroke under par, you actually beat what they say you should have got all your holes and like your golf balls in the hole. I'm not a golfer, so I don't really understand that, but I do know how those scores work. And then also in science, when we talk about electricity, there's positive and negative charges. And then another thing that we as adults know is when we are banking. And so negative is when you've done a withdrawal, and a positive is when you've added. Also, sea level, when you're talking to grade 6 kids, you can talk just about the fact of a lake. You don't even have to talk sea level at that point. You can just say, if you were to consider the surface of the lake is 0, and if you go below the water, you're going below sea level. But that doesn't necessarily mean sea level is in the lake in Alberta, but just when we're talking about, so that they can understand what that means. And then a fisherman's location would be above. If I'm sitting in a boat, I'm above the water. So that's a positive number. If I'm below the water, I'm a negative number. Now, what we really need to make sure that we teach in grade 6 is the kids understand the symmetry of the number line. And that for every positive number, there's a negative number that is the same distance from 0. Okay, so for example, if something positive 6 is the same distance from 0 that negative 6 is at. So the number, everything is compared to 0, and we want kids to know that every positive number has an opposite negative number that has the same magnitude. And magnitude is how far is it from 0. So we call numbers and their opposites additive inverses. And this is huge, very, very important that kids really understand this, because if you have a positive, like a positive 1 and a negative 1, because they are equal distances from 0, if you were to put them together, they will equal 0. Okay, so call attention when you're teaching this using a number line. Call attention to the fact that the spaces between the numbers has to be the same throughout. So on a thermometer, for example, the spaces are in groups of 10. On our number line in our classroom, it could be a group of 1. You could also have a group of 2, but the space has to be the same from 0. So if this is positive 2, that same amount of space on the other side of 0 would be negative 2. So really make sure when kids are doing those number lines that that's what they have, that they understand. Okay, and so I've already said integers are numbers that have the negative or the positive sign, and really if their number does not have a sign, we know that it's positive. And so by the time they've gotten to grade 6, only thing that they've worked with is positive numbers. Now, when they get to grade 9, they will use negative fractions and negative decimals, but those are not called integers. Those are called rational numbers. Integers are whole numbers that have a sign. Okay? If I'm losing anyone at this time, let me know. So, using that number line, we can also make it really easy to compare a number. So anything that is to the left, so you can start by showing the kids the positive numbers, and you can say, okay, look at the number 2 and number 9. What number is less than, is 2 less than 9, or is 9 less than 2? And they should be able to say, well, I can see it's closer to 0, so 2 is less than 9. Well, the same thing happens when we go to the other side of 0. If we're going to the left, the further we go to the left, the smaller the number. So now what we want, kids will get often mixed up and they'll say, well, -2 is equal to +2 because it's the same distance from 0. No, we're talking about the fact it's further to the left of 2. So but when it's to the left of 2, it's smaller. Just like 0 is smaller than 2, -2 is smaller than 2. And so I honestly, when I was teaching grade 7 and I taught this thing, I often used to get the kids to think of temperature. What's colder? -2 or +2? And the colder the number, the smaller the number. So it really does help. And especially if you do turn it upside down vertically and you talk about the thermometer, you can let them know that the warmer it is, the bigger it is. Okay, does that make sense? So one of the activities from Mythology is that they have to order the elevations from lowest to highest. So once they understand this, once they have a really good understanding of, larger and smaller numbers, then you can do something like this and say, okay, let's just take a look at this elevation. Which is the smallest number? Which is the lowest number? What is the furthest number under the sea? And the number in this case would be negative 430 meters. So also think about this. That's the Dead Sea. It is 430 meters below sea level. And so on your slide, you'll notice I gave you a link. This will actually take you to the Wikipedia page where this came from. And it's really interesting for kids to take a look at, even look where Edmonton is in comparison to sea level. And let them think about it. And so talk about like the mountains, talk about where is sea level in Canada? Where would be sea level that is closest to Edmonton? Well, it's in Vancouver. Okay, but this is interesting for me that like the Dead Sea is actually below sea level. Like it's crazy. Whereas when we look at something like Lake Erie in Australia is only 16 meters below sea level. Okay, so this understanding is so important. If they master this in grade 6, their work with positive and negative rational numbers, for example, -1.5, as well as working with polynomials and factoring and rational expressions and quadratics in high school, it'll be so much easier. But I cannot stress how, don't just assume because this is really easy for us to say, yeah, they got it. Have them, remember that word, express. Have them express their knowledge. Have them tell you. So the next slides are all the manipulatives. And this is another, he used to be a consultant for Edmonton Catholic, and he retired many, many years ago. His name was Enzo Timoteo. And Enzo made all these slides. And so special thanks that he has allowed me to use them during my sessions. So we want to use manipulatives, especially when we're teaching this unit. I know there's a lot of people that just teach the kids the rules for adding and subtracting. And if the thing is, you shouldn't have to memorize anything, because if you really understand, you just understand. You don't have to have some rule that if you forget, then you can't do any of your math. Okay, so we're going to use manipulatives, and what I really like to use is colored tiles. Just if you have tiles that they come square tiles that are different colors, and the color tile, like I have boxes of different colors, but I also have tiles that are red on one side, white on the other, blue on one side, white on the other. I love to use those because I saw this once. When I listen, I hear. When I see it, I remember. But when I do it, I understand. And really, that is true. And if anyone has ever taught kindergarten or grade 1, you really get that part. You understand how important these manipulatives are. So, first of all, what I want you to know is you're the human. You decide what color is positive and what color is negative. Don't change it around. I often will get teachers that'll say to me, oh, that's not what our PAT exam had. Our PAT exam had black and white. And I was just reusing red and yellow. Well, then tomorrow switch it to red and white. The day after, switch it to blue and green. But so that they understand, they decide what color it is. So I just decided that I'm going to use red to show +2. So 2 squares. +3 would be 3 squares. So these slides are going to be yours. So all you do is say, okay, show me, what does +5 look like? Then, okay, what color should we use for negative? And I just arbitrarily decided white. So show me -3. Show me -4. Show me -7. Okay, how simple is that? But really make sure that they know that you've decided as a group, or you, the teacher, has decided what color is positive, what color is negative. Okay, so now you've shown me -7 and +5 and whatever. This is very interesting because now you need to know that if I was just comparing the number of tiles, -7 is more. But that's not what I want the students to do. I want them to know that really -7 is actually colder than +5. It's further away from, it's further on the left from +5. It is a smaller number. Okay, so don't get them confused with saying, well, there's more or less white or red. So again, just decide what color each one represents. Okay, the other thing is now, if of anything that I've said, identifying the sum of 0 is probably the most important thing that you can teach them now. So what you have to show them is this. Is this equal to 0? Just yes or no, thumbs up, thumbs down if you, okay. Yeah, it is. Why? Same magnitude, same size is putting them together, you get 0. How about this? Absolutely. You're not changing, we've just changed the size of the tile. Okay, how about this? No. Same size, same shape. This is different sizes. And so that green one could actually be equal to 4 tiles altogether. Like it's 4 times as big as the other one. So it has to be, you have to use the same shape. So in other words, I can't use a bingo chip and a square. No, not equal. So the other thing here is when you're doing, you think about it when I'm using fractions and I'm talking about the size of the whole, it's got to be the same size. Okay? No. How about now? Thumbs up or down? Okay. No, because, oops. No, because this green and this white are zeros. Oops. This white and this red is 0, and you're left with a -2. Okay, same size, same shape, opposite color will give you 0. So for example, +1 plus -1 equals 0. Guess what you just did? You started adding integers. So watch this. If you were to ask your kids to add with integer tiles, man, I used to love doing this with my kids. They could not believe how easy it was. For example, +2 plus +3. Start off +2 plus +3. What do you have on your desk? +5. That was simple. Okay, how about this one? -2 plus -1. I have -2 plus -1. How many in total? -3. Oh my God, this is simple. And then do a lot of these. Do a lot of just of the same sign and positive, just do a lot and ask them, do they see a pattern? Well, the pattern is you're just adding and you're using the sign of both integers. But a lot of teachers might just jump right into this and say, you know what? I am going to just tell them the rule. But if they don't understand why that rule exists, they're going to forget. So this is simple. And now I'm going to jump into something else. Watch. -3 plus +2. So I'm going to have -3 and +2. What do we know already? We know that we know the sum of 0, don't we? So we know that that and that is a 0. We know that this and this is a 0. What are we left with? -1. Okay, look at another one. -3 plus +4. So I have this. Just by looking, I know that that's a 0, that's a 0, that's a 0, and I get an answer of +1. So I honestly, when you're doing this in your classroom, don't deal with sums more than 20 at the beginning. Just let them do this and always ask, how many 0 pairs do you have? Move them off to the side. Do this until you get the answer. Now, the next phase before subtracting, I would do, let's build combinations of -2. Well, I know that. Is that -2? Absolutely it is. And what you want to make sure when you're teaching this about positive and negative is, and especially when you're subtracting, you can always have lots of zeros on your desk. Okay, so that's a 0, that's a 0, and that's a -2. Another example of -2. And all I did here was I show you that I can have lots of zeros, but it is a -2. So very, very quickly, I'm just going to show you, basically, I can have as many zeros on my desk as long as I have 2 extra negatives. That's -2. And so the same thing with this. Let's build combinations of +3. I can have lots of zeros. It doesn't matter as long as what I have is 3 extra positives. So if I look at this combination here, it's still +3. And that's really going to help when you do the subtraction, because here it is. Super simple. I have -3 and I want to take away +2. Do I have any positives to take away from that illustration of -3? No, I don't have any. So what I'm going to do is I'm going to add a bunch of zeros. And what I'm going to show is that I can't take away +2 because I don't have any red ones. But if I put a couple zeros down, I now have some red tiles on there. This still shows me -3, even though I added some zeros to it, but now I can take away the positive 2. And if I take away the positive 2, what do I end up with? I end up with -5. This is huge for our students to see. Okay, very, very important. So let's do one more. What I have is -2. Can I take away a positive 1? Do I have any red tiles there to take away a positive 1? Nope, I don't. So what I'm going to do is I am going to put on a 0. Now, can I take away a positive 1 from this -2? Yep, I sure can. If I take away that positive 1, what am I left with? -3. Questions? Okay, how about a -2 take away a -4? Well, I could take away -2, but I still don't have enough to take away. So how many zeros do you think I should add? You can put that in the chat. How many zeros? Yes, I should add 4 zeros. 1, 2. Whoop, mistake. I only added, sorry, I had -2 minus -4. So I only needed 2 more whites. So I only added 2 more zeros. So now can I take away 4 negatives? I sure can. If I do, what am I left with? I am left with +2. So I'm just going to go back to the very beginning because I did make a mistake with this one. I have -2. How many zeros should I add? How many do I need? How many more white tiles do I need in order to take away 4 white tiles? I only need 2 more. So I'm just going to add 2 more zeros. Now I have enough to take away 4 negatives. I take away those 4 negatives. I end up with +2. Let's try +2, take away -4. Do I have any white tiles here to take away the -4? No. So what am I going to do? How many? I need to take away 4 whites. How many zeros should I add on here? 4. 1, 2, 3, 4. Now I have enough whites that I can take away these 4 whites. And if I pull them off, I end up with +6. Please spend lots of time with your students doing this. Really empower them to understand how they did this, because they just, one of the rules is when we're subtracting, what we're really doing is adding the opposite. You may have learned that when we were doing this when you were in school, but before you teach them add the opposite, what we want them to see is, why do we add the opposite? So that they totally understand. When they understand that, then we are hitting that outcome that said to express differences as sums. And this is where it is a sum, because we are adding the opposite. So +5, taking away -3. Do I have 5 positives. Do I have any negatives to take away? No. What am I going to do? How many zeros do you think I should add? It really doesn't matter if I add 3, 4, 5, 6, 7, 8, 9, 10. It doesn't matter. I'll still have +5 shown. But to make life easier, I know I'm just going to add 3. Because as long as I have 3, I can now take away 3 negatives. When I take away the 3 negatives, what do I have left on my desk? 8. +8. Okay. So just give you some time to do these extras. Positive 5 minus positive 6. My first question would be, what do you think is going to happen? Are we going to have a positive or negative answer? Okay. If I am taking away 6 positives from positive 5, I don't have enough. So I would have to add on an extra 0 so that I can take away. Okay. So, yep, once they really understand this, then they'll understand the rule of when you're subtracting, you're just adding the opposite. So, but don't just jump into the rule. Have them make that generalization. So, -4 minus -4 is 0. -7 minus positive 5 is -12. -5 minus positive 6 is -11. -5 minus -6 is positive 1. I totally love the Frere model. If you want to use something at the end of a unit and you want to see, do they understand what integers are? This is a great thing. You add in the center, you put the word integer, and then they have to define it. What is it? What are the characteristics? What are examples? What are non-examples? And so here is, I know this is kind of blurry, but non-examples of integers are positive and negative decimals. So the only thing that is an integer is a whole number. But we want kids to fill this in because this will really uncover their understanding and misunderstanding. Now, I want to say that Calgary Board of Education has done some really great work, and they are sharing with us, just as Edmonton Catholic shares their crates. Calgary Board of Education came along and they have shared with the province just tasks that you can use to for every outcome. And so if you wanted to take a look at this, when you take a look at this, what you'll see is they are just hyperlinked, and you can just put it in here. So if I was to go to this, it's in the ARPDC website, and it's called the Calgary Board of Education Grade 6 Math Tasks. You just have to click on the PDF, download it, and you'll have activities for all of your outcomes in grade 6. The other thing is I want you to make sure that you're aware of is gizmos. If you wanted to have kids use their own devices in class, you can always go to Alberta Ed, Alberta Learning, and whoops, I thought there. If I go to Learn Alberta, there is a gizmo here, and everything I showed you with tiles, you could do using the gizmo. So for example, this is +5 plus -2. And so I'm going to drag, this is yellow and red. So this is 1, 2, 3, 4, 5. And then model the -2 by adding more chips. Well, now I have to add 2 negatives. And now, oops, sorry, I made a mistake here. There we go. I have +5 plus -2. And then what I want to show kids is if I drag this on top, it actually disappears. It becomes a 0. And what I'm left with is +3. So this is an interactive site, Gizmos, on Learn Alberta, which is free. Learn Alberta has purchased the rights for all Alberta teachers, and all you have to do is sign in and you can use it. And then the student version, they can use without signing in. Now, when there's another thing you could use is the number line. I really like this because you can, the first digit, for example, oh, let me just go to this. This is the actual gizmo. And I can say +3 plus 3. And so we can see how this just moves, and the answer is -6. But I can move this and go, I started with +3, but I've added -6. So I ended up at -3. And you can show this interactively on your whiteboard. Great little tool. The other thing you could do is you could show subtraction, and how subtraction, what happens when you start at 3 and you're taking away -6. What you're doing is you are actually adding a +6. So my only thing with this is, please don't show this until they really understand with the tiles what just happened. And then you could show them on the number line how when you're subtracting, all you're doing is you're adding the opposite. Okay. I hope I haven't left anyone behind. Here's some upcoming math sessions that we are having, and just so for your information, on Thursday, my colleague Betty is doing a session for grade 6 teachers on the geometry unit and coordinate geometry. And then there is, on October 25th, I am doing a session for fractions and operation of fractions, and then a new math curriculum for grade 6 teachers. And then on November 2nd, Betty is doing a session for grade 5 and 6 algebra. And then I'm doing 2 sessions, one on the 13th, that is addition and subtraction strategies for whole and decimal numbers. And on the 20th, I'm doing strategies for multiplication and division. We often hear teachers say that they don't know their basic facts. Well, I'm going to be offering you the information on strategies where, rather than trying to teach kids basic facts by memorization and strategies, I'll show you some strategies that if kids know these strategies with whole numbers from 1 to 10, then they will know them with any whole or decimal number. I'm a really firm believer in don't teach a strategy unless you can use it with all numbers. And then on November 23rd, for grade 4 to 6 teachers, I will be doing a session on teaching prime, composite, divisibility rules, square numbers, factorization for understanding. So different strategies for those topics. And on that note, I promised you it wasn't going to take us an hour and a half. It is 4:30. Thank you very, very much for joining me today. You can stay on if you have any questions. But that is the session for today. So thank you very, very much for joining me.
Thank you so much.
Thanks, Larissa. You are awesome. I really appreciate it.
Well, this helps me a lot because we're just starting integers actually right now. Like we just finished relative frequency and we're doing integers like starting this week. So this is like really great. I'm going to rewatch this today and then just 'cause I missed a little.